So this is going to basically be a review of sections 1 through 4. And the idea is we'll put all the different kinds of factoring problems together and then pick the appropriate strategy. So here are some guidelines for factoring. And we might have looked at these just a little bit at the end of class last time. I believe we did. We'll keep going back to these in just about every class meeting that we have remaining. So, step 1 on any factoring problem is ask yourself if there is a common factor. So that's the first question we ask. Is there a common factor? Sometimes there will be one we can factor out, other times there will not be one. If we can factor one out, we need to factor it out. Okay, and then after that, we look at the number of terms. The number of terms determines which of the factoring strategies we will use. If there are 4 terms, we will do grouping. If there are 3 terms, we will use the AC method. Which turns it back into a polynomial with 4 terms. Now, if there's a 1 on the squared term, then we can use the shortcut. So sometimes, if it's the AC method, we'll ask a second question, can we use the shortcut or not? If there are 2 terms, which is what we did last time, the first thing we'll check to see is if we have the difference of squares. And if it's not that, then we'll check to see if it's the sum or the difference of cubes. So let's pull up some factoring problems, and using these guidelines, let's get them factored. So you want to keep those guidelines handy as we approach these problems. 2m squared minus 10m minus 48. Okay. So first things first, do you see a common factor in 2, 10, and 48? Let's take a 2 out. Good. That'll leave m squared. 2 out of 10 leaves 5m. 2 out of 48 leaves 24. Okay, now we need to see if we can factor what's inside the parentheses here, this m squared minus 5m minus 24. That has So we count the number of terms. How many terms does it have? It's got 1, 2, it's got 3 terms. So if we can factor it, it'll mean we would factor it by the AC method. And we can use the shortcut because this m squared has a factor or a coefficient of 1 there. So 1 times negative 24 is negative 24. Okay, so we look for the factor pairs of 24. And so the first thing we do to do that is we square root 24. If you punch in the square root of 24 on your calculator, it's going to tell you 4 point, and it's going to give you a decimal. The 4 is really the only part that's important, because that tells us where to start. So we're going to start checking with 4. We'll ask if 4 goes into 24. And it does. It goes in 6 times. So to get negative 24, I could either take 4 times negative 6 or negative 4 times 6. Now what we're looking for is we're looking for the combo here, over here, that adds up to this middle term here. Negative 5. Neither one of those do. They add up to negative 2 and positive 2. So we're going to have to find other factor pairs for negative 24. So we'll back 4 down to 3 and ask if 3 goes into 24. And it does. It goes 8 times. So either 3 times negative 8 or negative 3 times 8. But 3 and negative 8 do add up to negative 5. So that's the combo that we need. So then how's it going to factor? We're going to go m and m plus 3 and minus 8. So there's our first one. 2m squared minus 10m minus 48 factors as 2 times the quantity m plus 3 times the quantity m plus 8. All right. Let's look at the next one. The next one I have picked out for us to look at is 50 z squared minus 100. Well, it's not the difference of squares because 50 is not a perfect square. But what we want to do before we check difference of squares is we want to look for a common factor first. And in 50 and 100, they have a common factor of 50. So we can factor a 50 out. $50 factored out of 50z squared leaves z squared. 50 factored out of 100, let's see, 100 divided by 50 would be 2. Now we want to check and see if what's left inside the parentheses, we want to check and see if we can factor it. Well, it's got 2 terms. And when we have 2 terms, we always check for 2 things. The first thing we check for is difference of squares. Well, z squared is certainly a square, but 2 is not a square number, so it's not the difference of squares. The next thing we check for is it the sum or difference of cubes? Well, z is not being cubed, and 2 is not a cube number either, so therefore it's not the sum or difference of cubes, so therefore this is all we can do with it. Just factor out of 50, and that's it. So that one's done. Okay, let's go to the next one. This time we're going to choose 8k squared minus 10k minus 3. So let's look for a common factor because that's always what we do first. And in 8 and 10 and 3, I don't see a common factor. So we don't have it to do on this problem. So I ask, how many terms does it have? Well, we've got 3, so this is going to be the AC method again. But this time we cannot use the shortcut because I don't have a 1 as a coefficient on the squared term. So we'll have to do it the long way. So what does that mean? It means we're going to leave 8k squared alone. We're going to leave negative 3 alone. Those two are going to stay the same, but we're going to rewrite negative 10k. But we got to figure out how we're going to rewrite it, and that's where the AC part comes in. So A times C here would be 8 times negative 3. It's always the squared coefficient times the constant, which is negative 24. As we saw earlier, if you square root 24, you get 4 point something. So that's where we need to start to check for all the factor pairs of negative 24. We're looking for one that adds up to negative 10. Let's see if we can find it. Okay, so we ask if 4 goes into negative 24, and it does 6 times. So either 4 and negative 6, or negative 4 and 6. But those add up to negative 2 and positive 2, neither of which is negative 10. So that's not it. So we back it off to 3. Does 3 go into negative 24? Yes, it does. 8 times. So either 3 times negative 8, or negative 3 times 8. But those add up to negative 5 and 5. So that's not it. So we back it off to 2, and we ask if 2 goes into 24. And it does. It goes in 12 times. So either 2 and negative 12, or negative 2 and 12. But 2 and negative 12 do add up to negative 10. So that's the combo I need. So what I'm going to do is I'm going to rewrite that negative 10k as plus 2k minus 12k. Now it's got 4 terms, so we can do grouping now, which is what we learned in chapter 6, section 1. So we'll group the first 2, we'll group the last 2. Remember, the minus has to stay on the 12. We'll slip a little plus sign in there to show that they're still being added. Then we ask, what can we factor out of 8k squared and 2k? And that would be 2k. 8k squared divided by 2k is 4k. 2k divided by 2k is 1. So we're left with 4k plus 1 inside the parentheses. Out of negative 12k and negative 3, we could take a 3 out, but we're really going to want to take a negative 3 out. And the reason why is we need this second parenthesis to match this first parenthesis over here, which is plus 4k and plus 1. So to be left with a positive and a positive, I'm going to have to factor out a negative over here. Negative 12k divided by negative 3 is positive 4k. Negative 3 divided by negative 3 is 1. And now you can see that our two parentheses match up. So that makes one factor, 4k plus 1. And the other factor comes from what's on the outside of those two parentheses, 2k and minus 3. And that one is finished. Well, let's look at a couple more here. The next one I had picked out was m squared minus 81. Here, if we look for a common factor, there is not one. So it's got 2 terms. So let's see if first if this is the difference of squares. Well, m squared is m times m. Yeah, 81 is 9 times 9, so this is the difference of squares. It's going to go m and m, 9 and 9, plus in one, minus in the other. Neither one of those factor. So we're finished right there on that one. Alright. Next, I had picked out 20 plus 5m plus 12n plus 3mn. So let's look for a common factor. None of them all have the same variable, so I can't factor a variable out. The only common factor between 20 and 5 and 12 and 3 would be 1, and that doesn't help me. So there's no common factor in the whole thing. So then, how many terms does it have? It's got 4, so we know that that's a grouping problem. So out of 20 and plus 5m, what are you thinking there?
What do you mean?
What can you factor out of 20 and 5m? Let's take a 5 out. 20 divided by 5 is 4. 5m divided by 5 is m. What about 12n and 3mn? What do you think about that? Good. Excellent. 12n divided by 3n is 4. 3mn divided by 3n is just m. So we got what we wanted. We got these two parentheses to match up. Okay, and remember, when we have grouping, when our two parentheses are the same, that's going to make one factor in our answer. And the other factor comes from what's on the outside, 5 plus 3n. So we've done almost every kind of factoring problem here.
I'm just surprised on you what factors to take out when it comes to grouping.
You did well. Here we had an AC method where we were able to use the shortcut up here on this first one. On this second one, we could factor out a common factor, and there's nothing else we could do. Here we had an AC method with no shortcut. Then we did a difference of squares problem with no common factor. We had a grouping problem. There was only one other kind of problem we looked at this chapter, and that was the sum or difference of cubes. So the last problem we're going to practice on is 8a cubed minus 27. And yeah, it's going to be a cubes problem, but let's think through how we would get there. Okay, so the first thing I would do is say, do I have a common factor? And I do not have a common factor here. The next thing I would look at is the fact that it's got two terms. Well, if it's got two terms, first I ask if it's the difference of squares, and it's not, because 8 is not a square number. That's enough, but a is also not a square, and 27 is not a square. Then I ask, is this the sum or difference of cubes? And if you remember our list from last time, the cube, the number that goes with 8 is 2, and the number that goes with 27 is 3. So this would be 2a cubed minus 3 cubed. And that's how I encourage you always to start, is to write it as something cubed and something cubed. And once we get that done, remember the 5 things we need are a, b, a squared, ab, and b squared. Well, our a and b are determined for us now. They're 2a and 3. Those are the things that are being cubed. So if a is 2 little a, then a squared would be 2 little a times 2 little a would be 4a squared. And ab would be 2a times 3, 6a. And b squared would be 3 times 3, or 9. And then we're just going to put it all in that formula that we learned, which for the one that was subtraction went 2a minus 3. It was a minus b in the first one. And in the second one, it was a squared plus ab plus b squared, which in this case would be 4a squared plus 6a plus 9. So what is the moral of the story here? It's that process. I mean, you need to know all the different types of factoring, but to get to the right one, it's 2 questions. The first one's always, is there a common factor? The second one is, how many terms do I have? Remember, if it's got 4 grouping, 3 AC method, 2 difference of squares, or sum or difference of cubes.